Hello there. Welcome to math, 6th grade math. This is your first lesson, your first official lesson of 6th grade. I'm glad you're here. We might as well get started. Now each lesson we're always going to start with today's big idea. It's the goal, and it's the big thing I want you to take away from the lesson by the end. I always want you to write this on the top of the page of your notes. So it should say today's big idea or goal. Learn to estimate with whole numbers. Make sure you have the page number at the top as well. Every number needs to be paged in your notebook. And also today's date. If you forgot today's date, I'm sure you can figure it out on your computer or look at the calendar. Pause the video, write this stuff down, and come back when you're ready. Okay. Every lesson after our goal or our warm-up, our goal or our today's lesson, we're going to start with an APK, which means accessing prior knowledge. The other thing you can think of it as is a warm-up. So here's your warm-up for today. You have looks like a bar graph about aluminum can collections from 6th, 7th, and 8th grade. And it shows on the number of cans they got. So Harvard Middle School is collecting aluminum cans to recycle for a fundraiser. The number of cans that each grade collected is shown. What you need to do is answer the 3 questions that are on the right. So pause the video, answer them in your notebook, make sure you put the subheading warm up, and then you can start working on them. And when you're done, come back and we'll see how you did. Good luck. So here are my answers, and yours might be close, yours might be a little different, and that's totally fine. So here's what I came up with. So number 1 is to estimate the total number. Well, I decided to round the 8th grade to about 600. 7th grade to about 500, and 6th grade to about 600, made for easy math. I got about 1,700 cans for number 1. Then it said the principal announced that there are nearly 2,000 cans that were collected, and that was the principal. And the newspaper said that there were over 1,700 cans that were collected. So the second question then says, is either of these reports correct? And I said both are, basically because both are an estimation. And number 3 then says, why are the reports different? My answer was, well, it depends on how the estimation was done. I'm pretty sure that the newspaper did exactly what I did, but the principal may have rounded differently. I wonder how the principal rounded. If you think you know, write it down in your notebook. Okay, now that we have the warm-up done, our brains are now into math mode, we're starting to think properly, it's time for us to move on and start doing a few example problems from our reading. All right, so when you're ready, move on with the video here. All right, so what we're going to do is we're going to take a few notes here, and I'm going to want you to put these notes in your notebook. Now, the one thing you're going to notice up here is I have some words that I bolded and underlined. I'm going to call those vocabulary words, and those must be in your notes. So you're looking at these 2 paragraphs probably wondering, what exactly do I need to write down? Well, only the definitions are really that important. So let me talk through, and even today I will help you by starring the areas that I think are most important. Now what we did in our warm-up and what we're going to do today in class is we're going to do something called estimating. You don't always need the exact number to be able to solve something. Sometimes you just need to estimate. And what does estimate actually mean? Well, estimates are close to the exact answer, but are usually easier and faster to find. You've probably done estimating before. When someone asks you, how long does it take you to get home? Well, it may take you 15 minutes, 42 seconds, but you'll usually say, about 15 minutes. Okay? Estimates are very common. Now, when we estimate, really what you're doing is you're rounding numbers in the problem to what we call a compatible number. And what compatible numbers are, see me starring these things? Compatible numbers are close to the numbers in the problem. Okay? They help you do mental math, or do math mentally. And what we mean by math mentally is being able to do quick numbers in your head so you don't have to stop, grab a piece of paper, try to figure things out. If you can do it in your head real quick and easy, it makes math a lot easier. Now before you move on, I want you to pause the video and make sure you have these 2 definitions written down, because we're going to do some practice with these as we move on. So pause the video. I'll see you back when you're ready. All right, a couple other notes to note about rounding. Notes to note. Anyways, when you're rounding, you always want to look at the digit that the problem tells you to look at. look to the right of that place value, and it always tells you whether you should do rounding up or rounding down. And you've probably learned this rule before, but if a digit is 5 or greater in the number you're supposed to be looking to the right, if it's 5 or greater, you round up, which means the number you're looking at becomes bigger. If it's less, you round down. If you think you need to write this down, pause the video and go ahead, but I think this is something you probably already know. All right, so we're going to look at example 1. We're going to look at a practice problem here. So what I want you to do before we go on is make sure you have the subheading example, practice 1, or even easier, just example 1. Okay? And what are we going to actually do? You may want to write this. It says estimating sum or difference. Now sum means add, difference means subtract. So we're going to look at some problems where you have to add or subtract. Now if you remember the little note we just looked at a little bit ago, it's going to help us here in this problem. So here it says estimate the sum. So it says sum. So what's the problem want us to look at? It wants us to look at an adding problem. So we're going to estimate the sum by rounding to the place value indicated. In this problem, we're looking at 12,345 plus 62,167, and it wants us to round to the 10,000s. So we have to first be able to know where the 10,000s is. So if we look at each number, we're going to start at the far right, and it's the ones place value, then the tens place value, then the hundreds place value, then the thousands place value, and finally 10,000s. So 10,000s is the 5th number from the right of the decimal point. So let's look at the second number. Ones, tens, hundreds, thousands, 10,000s. So the numbers we're rounding to is this place value and this place value. Now like I said in the other slide, to figure out how that number is changed or not changed, we look at the number to the right. So in this case, that would be the 2. For the other one, it's also a 2. So we have to determine, based on that number, does that make the 6 or the 1 go up, or does it keep it stay the same, keep it down at what it is? Well, 2 is less than 5 in both, so these would mean you round down. So we're going to go from 12,000 to just 10,000, because it told us just look at this place value. That's the only number that does not become a 0. So we put a 1 there, and then all these become zeros. And if we look at 62,167, 6 rounds, it rounds down to a 6. So we keep the 6 there. Everything else becomes a 0. Now you can do what we call mental math, because you've found compatible numbers that are really easy to add. All you have to add is 6 and 1, and you know that 6 plus 1 gives you 7. You just add the other zeros in there, so the sum of this number is about 70,000. It isn't exactly 70,000 because we're rounding. The other symbol people usually put in front of the number are these squiggly lines. That also means about 70,000. Okay? So I want you to write down these notes, this example that we have here, in your notebook so you have a good example. The example I have written down here, write down the notes you see on the board, copy those down before moving on. Now here's a second problem. You don't have to write this one down if you don't want to. This time we're going to estimate the difference, so that means we're looking at a subtraction problem. And this one we're going to be rounding to the thousands place value. So let's see if we can identify the thousands. In the first number, 4,983, 3 is the 1, 8 is the tens, 9 is the hundreds, 4 is the thousands. So that's the number that we're going to be determining if it goes up or down. And in 2,447, 2 is the thousands place value. So again, we want to look to the right, and the number to the right is a 9, and the number to here is a 4. Now a 9 is higher than 5, so that's going to make this number go up. So 4 becomes a 5, and everything after it becomes a 0. The 4 here for 2 is less than 5, so it brings it down, which means we just keep it at a 2, and everything else becomes a 0. So it's rewritten properly here, where all we have to do again is just subtract the two numbers, 5 minus 2, and I know you can do 5 minus 2. That gives you 3. These zeros, those are easy to do, so you have here 3,000 as your final answer. So by estimating, we got a number that's easier to work with in our head using compatible numbers and doing mental math. And we're able to estimate a close guess to what the numbers are. We don't have to know the exact answer in this scenario. So the nice thing is we know that 5,000 minus 2,000 would be a difference of about 3,000. Again, you can write this down if you want. If you don't feel you want to, that's fine. We're just going to continue on. All right, you're going to add the notes subheading once again. And there's a couple other notes I want you to write down here today. Those being these fancy words that say overestimate and underestimate. So what does that mean? Well, an underestimate, or an estimate that is less than the exact answer, that is considered an underestimate. And I even give an example here. 6,200 or 629. You can see that I came up with 600. So I rounded down in this example. It's still okay because it's an estimation. An estimation that is greater than the exact answer, we call that an overestimate. So in this example, I used 677 and rounded up to 700. Okay? Why? Because they're compatible numbers. They're easy to work with. It's okay to round down. It's okay to round up. It all depends on the situation. Sometimes underestimating is better than overestimating. And sometimes it doesn't matter. You can just pick and choose. We'll go over a few scenarios so you can feel comfortable with it. Make sure you have these down before moving on. All right, so here we go. We're going to look at practice or example number 2. Okay, number 2. Because we're looking at our second thing that we want to look at today. And here what we're going to do is we're going to estimate a product by rounding. Now, product means multiplying. With multiplying, compatible numbers is very important. There's so many different choices you can have. But with multiplying, you want to pick numbers that are easy in your head. So let's look at the problem. You can read it with me. Just look at the screen while I read. It says Chelsea is planning the annual softball banquet for the 8 teams in the region. Each team had a total of 18 members. And Chelsea wants to estimate how many plates she's going to need for the banquet so that enough people will attend. Well, 18 and 8, you can try to find numbers that are more compatible. It's okay in this situation to probably overestimate because what you want to do is you want to have more plates just in case than less. So an easy way to overestimate is move one of the numbers that looks a little more difficult. For me here, I thought 18 was the number to change, so I changed it to 20. Now, why is that so much easier? Well, really, all I have to do is I have to do 8 times 2. And I know that 8 times 2 is 16. And then I have to add the 0 in the ones place value from the 20. It's a placeholder. So I add it here right after the 16. I get 160. So the actual number of softball members we know is less than 160 because we know each team doesn't have 20 members. We know it has 18. But this is an example of overestimating. And here we're saying that Chelsea should buy about 160 plates. If she has a few extra left over, it's not going to probably terribly cost too much more, and you know that you're safe by having enough. So for the notes, what I want you to do is I don't want you to write the entire problem, but I do want you to write down this information because this shows how you think through an overestimating situation. Once you have this down, then you can move on. So pause the video and I'll see you in a little bit. Okay, not to confuse you, but let me show you another method. You don't have to write this down. Again, 18 members on 8 teams. Chelsea needs to buy enough plates. What could she have done? Well, what she could have done is she could have overestimated again, but instead of changing 18, she's going to change the number 8, so the number of teams, to 10 teams. Now this math is easy to do because it's 10 times 18, or to make it a little easier, you can think of it as 18 times 1. 18 times 1 is 18, but then we still have to put that 0 placeholder in the ones place value right here. You get 180. Now Chelsea has 180 plates. We know it's even higher, but she's still okay because this is an example of where you want to estimate. All right, here's another problem that we can look at. It says Miss Oliver wants to buy, and you don't have to write this down unless you want to. Miss Oliver wants to buy an entire 7th grade new pencils. There's 5 7th grade classrooms of 28 kids each. Estimate how many pencils Mrs. Oliver needs to buy. Now, before going on with this problem, why don't you pause and see if you can figure it out. See if you do what I do. All right, let's see if you did what I did. So here I've decided it's easier to overestimate. I'm going to change the number 28 to 30 because I can do the math pretty easy here. I know that when I move 28 to 30, I'm looking at 5 times 3, which is 15. Then I just got to put that 0 placeholder there. So if Miss Oliver bought 150 pencils, she'd have enough. She'd have more than enough, and that's fine. It's an estimation. All right, we are going to just skip this. Don't worry about it. Here we go. All right, so here's practice number 3. There's a third piece to this problem that I want us to try. And here what we're going to do is we're going to estimate a quotient. All right, so we've done adding, subtracting, multiplying. You probably know quotient as a division problem. So here we're going to want to use compatible numbers. And compatible numbers can be a lot of different things. We just need to find 2 numbers that are going to give us a 0 remainder or no remainder at all. Hate remainders. Ugh, makes division so hard. So here is Mr. Demel, and we see Mr. Demel will be driving 243 miles to the fair. He's going to drive at 65 miles an hour. Let's hope he's on the highway and not through small towns. About how long is it going to take him to get to the fair? Now, 243 divided by 65, that's going to give us a big number. So can we find compatible numbers? Yes, we can. And here's what I did. I decided to underestimate. And I only underestimated one number. What I did is I changed 65 to 60. Now from here I know I can do some easy math. Little trick I learned in dividing, if both numbers have a 0, you can cross those zeros out and not worry about them. Now I have 24 divided by 6. And I know 6 times 4 gives me 24. So the 4 goes over the 4 because I was dividing. No remainder. That makes it a good number. So I underestimated. I said that Mr. Demel, it'll take him about 4 hours to do the trip. So that's underestimating, so it might take him a little longer, but at least you know that he will be there at 4 hours. Could be a little under, a little over, but about 4 hours is what his trip's going to take. We don't need to know super exact. Okay? Again, like last time, I want you to have this along with your heading before moving on. All right, we're going to look at another one. You don't have to write this one down unless you want to. I encourage you to try it, though. You don't have to write the notes. It says, Mrs. Blair will drive 103 miles to the airport. She's going to travel at 55 miles an hour. How long will it take her to do her trip? Now, if you look at this, there's different answers you can probably have, but I want you to pause the video and think of compatible numbers that you could use. Okay, let's see if you tried and how you did. So here's what I did. I underestimated in this situation. I actually changed 2 numbers. Do you see that? I made the math a lot easier. I changed 103 to 100 and 55 to 50. Nothing wrong with changing both numbers. I didn't change them a ton. I dropped 5 miles an hour off the original problem and 3 miles off the entire trip. Now, again, remember the rule, if they both have a 0, you can cross out 1 0. Now I just have 10 divided by 5, or 100 divided by 50, same thing. How many times will 5 go into 10? The answer is twice. So Mrs. Blair is going to take about 2 hours to do her trip. And again, that's an estimation, and that's okay. It's totally fine to do estimations. And look how quick the math is when you do this. I probably didn't even need to write on the board. I could do those in my head. I know that 50 goes into 100 twice because I like to think money. And I figured if I have 50 cents and another set of 50 cents, that makes $1. All right, if this is feeling pretty good to you, I want you to give me a thumbs up across the room. Thumbs up across the room. If it's thumbs down, you got to come tell me what you're struggling with so we can try to work on this. All right, we made it to the lesson quiz. Now it's your turn to try to show me how prepared you are with this information. Announcements. So you have 5 problems. I expect to see each problem done in your notebook showing your work. So for the first 4, you're estimating to a specific place value. Number 1, it says thousands. Number 2, it says 10,000s. Number 3, it says thousands. Number 4 says 10,000s. So remember, thousands, 10,000s, thousands, 10,000s. Those are the numbers that are going to be not a 0. Everything else is going to be a 0. Good luck finding those. And for number 5, it says 1 quart of paint covers an area of 100 square feet. How many quarts are needed to paint a wall that is 8 feet tall by 19 feet wide? Remember for this one, area, an M, area equals length times width. Okay? You're going to need to know that to be able to figure out 8 times 19 or 2 compatible numbers. Okay? So how many quarts of paint are needed to fill a wall that big? Make an estimation, and you got to figure out how many quarts you're going to need, because every quart is going to be 100. It's going to be a tricky question. Good luck to you. And when you're done, you're going to bring your quiz, your whole notebook to me, and I'm going to check it over. And if it looks good, you're ready to move on and get your homework, and I'll tell you what that is when you see me. All right, you made it through your first lesson of 6th grade. You should feel proud of yourselves. Give yourselves a big pat on the back, and we will see you next time.